So that's our final pass here. We are just hogging the last 210 out, and then it should be done. I increased the speed a little bit to get a better surface finish, but that's pretty much what that. Alright, let's measure it again and see where we are. So you're right at 314.5. I think I do a spring pass to get a little bit of clearance, because we need a little bit of clearance, and then I think we're alright. So we're done. We had just under 315, so we got 0.25 clearance each side, millimeters. We need to chamfer it, good chamfer, otherwise the other side doesn't slip in. We need to scribe the bolt circle and we'll skim the outside, at least some part of it, so we have a clear surface for indicating, and so we can indicate here and on the outer surface and perhaps on the inside, but I think no, it's not possible because I'm going to clamp it here, so we're going to do it on the outside. I just need to find a left hand tool. Yeah, I had it on dimension, and but it was hot, so I was waiting a bit, and it was about 310, shrinking. I was expecting that. It's pretty cold at the moment, so anyway, let's chamfer it and do the outside. So we're doing the OD, and when it hits the weldings to stop the rattle in the back here, just use a block of wood and the backlash, because the chuck is not loaded, so the back here is rattling like hell, and just break it a little bit, swipes the rust off, so it's okay. Yeah, that's the difference. So the back here is rattling, and if you break it, it doesn't do it. It's an old machine, sometimes you have to do some workarounds to get it working okay, because it ruins the tool as well, so it's going back and forth. So that will take a little bit, and we'll come back when we do the final here. So we got most of it roughed down, and that's it for today. We carry on tomorrow and make it nice. So we're almost done. We do our final pass, and we luckily found a left-hand carbide tool, or carbide tip tool. So let's just do another few hundreds. I increased the speed a little bit, and we're on our slowest speed rate, and yeah, looking good so far. That's our final pass. We do one spring pass and then we're done. That gives us a good surface to indicate here. I need to control the chips here, otherwise they go in the middle. And happy so far. Turned out well. The HSS tool suffered actually from the weldings. There were some hard spots or inclusions in it, and I killed the HSS tool. Anyway, let me finish that and then we'll continue on. So that's our last spring pass. Pretty much no cut of step. Full speed in back here. I don't know, I think it's about 200 RPM or so. And hopefully we get a good surface finish here. I just want to look at nice. It's no matter what we do here. Anyway, the machine is really noisy at this speed, but nothing I can do. So we got a nice surface finish here. Only a very few harmonics in the middle here because there was an interrupted cut, but this is great. I like that. Okay, and at least it proves we can turn 370 millimeters on that lathe. 380 maybe. It's possible on that machine. Didn't think that. Anyway, get a bit of a chamfer on the outside corner and scribe the line for the bolt holes, and then we're done on this side. Looks quite impressive. So we're just double checking our bolt circle because we have no calipers in the diameter. We just measure from the tool to the center, and it's 167, and I think we're there, so we leave it this way. We scribe the line here, and we'll double check it very closely with a ruler just to make sure we're in the right ballpark, but I think we are. And then we just divide it and drill the holes. Okay, let's turn it around. Sorry for the noise, the heater's running, it's cold here. So we dialed it in, and that's the best I can get, 500 or so. Here we got about 110. That's the best you can actually see the jaws. Let me check that. Oh, let me show that. You can see it's getting bigger every time when the jaw is passing. So we're distorting it already. So I would say we're fine. That's with some goodwill 500 of a millimeter. Great. So let's turn that face and basically make a mirror image of the other side. So that's a little bit of a recess here, and then it just protrudes it. Basically just a negative of this end. Because we have something with the same pattern which we need to get further apart. So we're almost on. Now we actually half a millimeter over, and but it's warm. It's pretty hot. So I'm gonna have a coffee, let it cool down, and then we'll come back and measure again. If it turns out okay, we're done. Deburring, obviously. If not, we just skim another 0.25 or so. It's not gonna be a press fit. It's gonna be a sloppy fit. We'll come back when the thing is cold. So we finished. We checked it when it was cold, and it was spot on. So we chamfer the corners, take it out, drill the holes, and then this one is done. Another one to come, a bit smaller. We had 42 millimeters. 40 was the target. More is better, so 42 millimeters, because I only had 45 thickness with 3 plates. That's good. So we punched it. Yes, you could do it with a dividing table or whatever, but it's pretty big, so it's actually too big for my table and it's too much hassle. To do it without a table, it's actually pretty simple. The angle is 45 degrees, so divide it by 2. Take the sine times 2, which is 0.765. Multiply it by the radius, and you end up with 127.5, and then just divide it. And once you end up at the same place at the end, you know you're right. I may explain that on a piece of paper eventually, but it's a pretty good way of dividing equal bolt spacings if you don't have a means of dividing that on a dividing table. Anyway, let's drill, or let's spot the holes, and then we'll drill it on the small milling machine. So that's our setup on the mill. I want to make sure these holes are actually going straight, so we just center it with a pin, and then we just drill it. Actually use a center drill first. Make sure we're actually on center. We can see the scribe marks, and here, then just drill it. The first is through, looks about right. To make sure it doesn't rattle, I just use a jack stand here on the tailstock, shimmed it up to the right position, and yeah, so we do one after the other. It's a bit of a laborious process, but the problem is they gotta be straight, otherwise the bolts are 3/8 UNF. They are a bit too short, we need longer ones. So we drill, I would say 10 millimeters. 9.3 is 3/8. If we drill 10 millimeters, that's fine. Got a little bit of clearance, should be alright. I can't film when the machine is running, it's so loud. Yeah, you can hear it. Caution, it's gonna be loud. Gearbox makes a hell of a noise of that thing, but that's how it is. Well, it just turned out it's better to trust no one. According to the spec, it should be 3/8 UNF, but I checked the threads in the other side where the thing goes, and it turned out to be M10 or something like that. At least an M10 bolt fits, so we need to drill a little bit bigger, because at 3/8 UNF 10mm would be fine, but at a 10mm bolt we don't have clearance. So we drill it 10.7, that's just a drill ahead. Yeah, good I checked it, otherwise I would do it again. Unfortunately the drill is a bit long, I just could fit it. Because if I adjust the head, I change the alignment, that's not something we want here. Okay, let's drill these holes, and yeah, with 10.7, and we'll come back when we're done. To center it, I just put a center in the drill jig and rock it until it actually goes into the center punch, and then I tie it down. I don't move the table, I just grab it down, lock it here on the quill, and then just tie it down, check it again with a magnifying glass, and should be alright. And then just tie everything down, make sure everything is solid. I crank up the mill head a little bit, so I got a little bit more clearance for the big drill. Hopefully that works better. The problem with that machine is the quill travel is very limited. So yeah, it's a toy, but it does work. Alright, let's carry on here. So we're the last hole. Caution's gonna be noisy. So that's 9 or so. We're gonna drill it to size and then we're done. Jump for the other side and then we'll test with it. So we're done so far. Someone mentioned why I didn't groove it. Just because it only needs to be held together. It's going to be compressed with bolts, and you can see there's still penetration here. Even the tack welds are still visible. So there's another tack here. These are TIG welded tacks, and these are stick welded. Pretty hot tacks again. So that's enough, and we'll leave it on the inside anyway, because I can't be bothered. There's no reason to make that pretty on the inside. Once we test fit it, everything is okay. We're gonna paint it on the outside and probably on the inside as well to prevent it from rusting. The surface needs to be oiled just to make sure it's not rusting. We can't have any paint there because it's a slip fit. Okay, let's clean it and test fit it. So, and that's where it goes. This is an engine with an SAE flange, and we have a generator with the same flange. The problem is that the distance for the flex plate wasn't enough because the flywheel is not an SAE flywheel. I didn't want to take anything of the flywheel off, so I made a spacer, and we also make a plate to fit the flex plate. That will be the next job. It does fit. Hopefully I can do that with a torch and the camera at the same time. 1 sec. Okay, so it fits, and that's what we wanted. So it's basically recess here, the ring, and that goes here. It's the same diameter here. We've got the 8 holes. Yeah, I need to double check what the holes are. Maybe they were 3/8 UNF and someone tapped it with M10. Common practice. I don't know. And obviously the whole thing is becoming a generator, which actually also heats my workshop with the coolant. The generator is 22 kVA, so that's about 20 kilowatts. Should be enough to run some heavy machinery. Anyway, I'm not going to check it on the generator side because I need to take the cable ties off. Sorry, it's pretty dark in here. Nothing I can do because that's the storage here. The generator has the correct dimension, even comes from China. It's the engine flywheel, which is not a SAE flywheel, but it's actually thicker, which is good because it gives you better response to any rapid load or something like that, so the speed doesn't drop that much. Just a bit more energy stored in the flywheel. So that's why I decided not to machine the flywheel, rather put a spacer on the flywheel, because we need, I don't know if that's visible, but there are some bolts sticking out here and we don't have enough clearance here. That's the reason why we need to come out a little bit. Yes, you can machine the flywheel, which is common practice, but I think it was about 15 millimeters. I would need to machine off the flywheel, and that's not a good idea. Not in a generator application. For a car engine it's okay to make the flywheel lighter, but in a generator you want to have as much as possible mass on your flywheel. Anyway, that's one of the mysteries revealed. Next job will be the spacer for the flywheel. We chipped it up already, but it's not gonna be coming today. It's late, Sunday afternoon, and I had enough for today. So we're happy it fits. I checked the bolt holes, put one stud in and tried all the bolt holes. They do fit, I'm surprised. So I divided it correctly. We now need to test fit the generator and measure the distance from the flex plate to the flywheel. So bolt that up and tighten it up, and then we'll determine the distance, machine the plate which goes between flywheel and flex plate, and that's about it. Thanks for watching. Thanks for subscribing. Until next time. Someone's gonna clean that mess up here. Might quite a few chips. Anyway, job done.